Okay, so I think we're going to start. So today, mostly we're going to talk about the equations. And if we have time, we're going to start with inequalities. So I just talked with another professor who's teaching for everyone else except you, except software engineers. He told me that they could only handle equations. So then we are going to also try to handle the equations. And if we have time more than that, we are going to try to handle the rest of the topics as well. So the equation is the mathematical expression which holds the two things together, which basically says that the two things and both of the sides of the equations are true, are correct, or are equal. So we usually have this equality sign. So just let me just choose. So we usually have this equality sign, right? And everything which is more lefter than this equality sign is going to be called as the left hand side, and everything which is more righter, it is going to be called as the right hand side. So essentially RHS. So you can see this in some papers and the books as well. So, and also later on, we're going to talk about the equations a lot. And I will just quickly tell you that this is left hand side or this is right hand side. Well, in general, what do you think? Why the equations are needed for? Why we need equations? Hmm? Anyone? Daniel Arbik, are you here? Is there any Daniel Arbik here?
Oh, I am here.
Baburjan. So why we would need equations? Or can you give me an example of the equation?
Yes.
What you're learning in programming? So have you already learned about some sequences like Fibonacci sequence or something like this?
No.
No. Oh, but do you know what is Fibonacci sequence?
Not actually.
Does anyone know what is Fibonacci? No? Okay, so it is a sequence which basically starts from 1, 1, okay? And in order to form the next one, what I have to do is I need to add the previous 2. It's going to be 2. What is going to be the next one?
2 or
3.
second. Oh, sorry.
The previous 2, okay? What is going to be the next one?
4.
5.
5. What is going to be the next one?
8.
8.
Sorry. 8.
Okay, the next one?
13.
13. 21, and so on. Okay, so this is called Fibonacci sequence. Okay, so in order to find the next term, you need to add the previous 2. Okay, so what you can do is you can express any nth term of the Fibonacci sequence using some equation, right? So you can say that, hey, the nth Fibonacci number, or let me call this as Fn, can be written as the Fn minus 1 plus Fn minus 2, right? So consequently, F3, for example, is going to be equal to F2 plus F1. So we can use the equation in order to describe what is Fibonacci sequence, okay? So we use actual equations in order to describe something. So in order to describe some natural phenomenon, physical phenomenon, or from chemistry or from biology and so on. And by solving the equations, we can predict the things, we can understand the things much, much better. So, so later on, I think in the next year, we are going to have some courses of differential equations, especially in the course of Calculus 2. Could you please mute your microphone? And whenever I ask it, you can just unmute. Okay, thank you. So next year, we are going to have some courses like differential equations, when we are going to describe the physical phenomenon using the differential equations. I can just give you a couple of more examples. So let's assume that you've got the metallic brake, okay, and you can measure the temperature, and the temperature is going to be uniform and the whole brake, and it's going to be, let's say, 20 degrees of Celsius. So let's assume that you've started hitting this metallic brake at the 100 degrees of Celsius. So what do you think what happens?
The last part of
Yeah,
the metal. I
yeah.
mean,
So this part of this metal is going to be heated up to, let's say, 100 degrees, right? And this heat is going to be conducted through all of the cells of this metallic brake to the right, so that the right cells are also going to be heated. Okay. So what we can do is, it appears, we can use so-called differential equations in order to describe how every cell, how temperature at every cell of this metallic brick is going to change over the time. Okay, and if we are able to like express this using this equation, and if we are able to solve this equation, we can basically simulate this metallic brick, right? So maybe it will be really interesting for some of the industry to develop a simulator, computer simulator, which basically knows how the temperature is going to change in a whole metallic brick over some time, in 10 seconds, in 20 seconds, in 30 seconds, and so on. Okay, so in general, the equations are used in order to express some natural or physical phenomenon, and the solutions of the equations are going to help us to predict and understand this physical phenomenon much better. Okay, so in this course, we're going to mostly talk about the algebraic equations, which involves polynomials, or the radicals, or the or rational expressions. Oh, by the way, so let me ask you, what is the polynomial? What is the polynomial?
Don't know, Professor.
Okay, for example, if I say 2x squared plus 3x plus 9 is equal to 0, is it polynomial?
yeah.
Okay, it's polynomial. So 2x plus 5 is equal to 9. It's polynomial. 5x cubed plus x minus 3 is equal to 0 is a polynomial. Then 9x in the power of 13 plus 5x in the power of 11 plus 6 is equal to 0 is also a polynomial. Okay, so you can see here that a polynomial is the combination of the powers of the x. Okay, but integer powers of the x. So if I write down 2x in the cube plus square root of x minus 3 is equal to 0, then this is not going to be a polynomial, because it involves rational power of x, right? So do you remember the square root of x can be written as x in the power of 1 over 2, right? Rational power of the x. So this is not a polynomial. This is not a polynomial. So in general, the polynomial can be written as in the form of an x in the power of n plus an minus 1 x in the power of n minus 1 plus an minus 2x in the power of n minus 2 plus and so on, plus a1 x1 plus a0 is equal to 0 is the general form of a polynomial. Okay, so the polynomial is the linear combinations of powers of the x. So we're going to talk about the polynomial so many times. So this is just let you know what is the polynomial. So whenever you don't understand some words during the lectures, please don't hesitate to stop me and ask, because I mean, it is natural that you probably don't know the notation in English for many terms. Okay.
Yes.
Okay, so the solution of an equation, sometimes we call this as the root of an equation, or sometimes we call this as the zeros of the equation, are the numbers, so that if you substitute them in instead of x, the statement is going to be true. For example, so let's say I've got this expression 7x plus 4 is equal to 11, and I need to solve this. So essentially, I need to find such a number for the x, so that if I substitute this with the x, so the left hand side is going to be equal to the right hand side. So of course you can, I think most of you can easily handle this equation. 7x plus 4 is equal to 11. But what I would like to do with you is I would like to try to see how we can solve this kind of equations step by step in order to understand the conceptual idea of solving the equations, okay? Or conceptual ideas of the equations in general. So let's say I've got 7x plus 4 is equal to 11. So what we need to do is we need to find the x, right? So we need to express x is equal to something else. So x should stay aligned. So everything around the x or the near the x should be simply eliminated. So in order to do this, I need to get rid of 4 first of all. So what I have to do in order to get rid of this 4 is I just need to subtract the 4 from here, right? But since I'm subtracting the 4 from the left-hand side of this equation, I have to do pretty much the same thing with the right-hand side of this equation. So I'm just going to subtract the 4 from here as well. Then on the left-hand side, I will have 7x because minus 4 and plus 4 are going to eliminate each other. On the right-hand side, I've got 7. And now, in order to just get rid of the 7 here in front of the x, I just need to divide both of the sides of this equation to the 7. So I need to divide the left-hand side of the equation to the 7. But since I've divided the left-hand side of this equation to the 7, I need to do the same thing with the right-hand side part. So that is why I will have x is equal to the 1. Okay.
Yeah.
In general, again, so I just didn't want to show you how you can solve this kind of equations. I just wanted to tell you that if you would like to solve the equations, you need to get rid of the everything around the x by doing some algebraic operations like minus, plus, division. And whenever you're doing some operations with one part of the equation, just make sure to do the same with the another part of the equation, because again, so you need to keep the balance between the two things. So let's try to solve this equation.
Yes.
So again, so if you would like to express the x in one side and all of the other things on the another side, so we need to try to do the similar operations. So I would, for example, just simply multiply everything to the x minus 2 in order to get rid of the denominator. Okay, so let's do this. So if I multiply left-hand side to the x minus 2, I will simply have 3x, right? And on the other side, I will have 1 times to this x minus 2. It's going to be x minus 2 plus this is 6 times to simply 6, right? Because x minus 2 and x minus 2 are going to cancel out. And I will have 3x is equal to the x
minus plus 4.
Plus 4, right? Okay, so I'm just going to subtract the x from both of the sides. So I will just make minus x from here and minus x from here, so that in order to get rid of this x's here, okay? So this is going to be 2x is equal to the 4. I'm just going to divide both of the sides to the 2 again in order to get rid of this 2, okay? And this is going to be x is equal to the 2. And this might seem to you as the solution. But please hold on. I mean, do you understand what we did in order to find a solution? Is we just wanted to express the x in one side and everything else in another side. And we did some operations around the x. And we just made sure to do the same operations with another side of the equation. Once I found a value which can be suited for the solution, I just need to check. And I can check whether this is the solution or not by just substituting this to the equation. Okay, so again, so the solution, so I think we should try to think and try to behave like computers. Okay, so what would computer would do in this situation? If I would ask a computer whether x is equal to the 2 as a solution, then what would the computer do? So computer would basically look up to the definition. What does it mean to be a solution of the equation? And the definition tells us that x is equal to the 2 is the solution if and only if you substitute this x is equal to the 2 to the equation, your equation is going to be true. Okay, I'm just going to do this. So it's going to be 3 times the 2 divided to the 2 minus 2, which is already like strange, right? Because we know that we cannot divide as a 2. Okay, so it means that I mean x is equal to the 2 cannot be a solution because I can't really substitute this. It's going to be 2 minus 2. I'm going to have division to the 0 on the left-hand side. I've got the division to the 0 on the right-hand side.
It's infinity.
Yeah. So I mean, I don't know what is infinity, right? Okay, so there are different measures of the infinity. We are going to talk about this definitely later. But so far, we just know, we just need to keep in mind that we cannot divide this as 0. So that is why this equation doesn't have a solution, no solution. Conclusion from this exercise, an example, is that you have to always check your solution by just putting this back into your equation, okay? So sometimes you're given this kind of equations where you need to express one of the variables using the other variables. And in order to do this, we're going to do the similar operations again. So we are going to write down this R1 just alone without all of the other variables. In order to do this, definitely, I would just put this term to the left, okay? So it's going to be 1 divided to the R minus 1 divided to the R2 is equal to the 1 divided to the R1 minus plus 1 divided to the R2 minus 1 divided to the R2. So what I did is I just subtracted 1 divided to the R2 from both of the sides of the equation, okay? And because the idea is I would like to get just rid of this R2 on the right-hand side part. Then on the left-hand side, I would just give a common denominator. It's going to be R2 minus R1 divided to the R1 times the R2 is equal to the 1 divided to the R1. Oops, sorry, it is simply R. R here, okay? So now if I would like to find R1, I would just flip over these two fractions in both of the sides of the equation. It is going to be R times the R2 divided to the R2 minus R is equal to the R1. So this is how we would just express the terms. And I would just again call this as a solution, because if I would just substitute this into this equation, this would be true, right? So you can easily check this over. Okay, so what I wanted to do with you now is I would like to simply talk about the percentages. Do you know that, oh, you probably don't see this, right? Okay, well, we'll come back to this. So do you know that accountants and engineers calculate percentages of some numbers in a very different way? So if I ask, so from my experience, whenever I used to go to my accountant and ask her to calculate, for example, like 20% from 5,000, what she would do is she would take a calculator, calculate 20% of 5,000 first by just like typing 5,000 percentage 20, and then add this to the 5,000. Okay, so it's going to be like a 5,000 percentage like 20, and then plus the 5,000. Okay, you can try to do this in your calculator as well. And this is going to be equal to actually 6,000. Okay, so what do you think what the engineer would do in this situation? So how an engineer would calculate 20% plus to 5,000? 5,000 plus 20%. So if I just say you, hey, could you please tell me what is the 20% plus the 5,000? How you would calculate this?
5,000 maybe cut for 5.
You would just multiply this as a 1.2. Okay, so if you just multiply 5,000 to the 1.2, it is going to be again 6,000. And you can do this without actually calculating what is the 20% of the 5,000. So this is very like, I think this is the fundamental difference in thinking of the two different professions. Like accountants think differently than the engineers. So I would like to understand what does it mean, this 1.2, and where does it come from? So whenever you need to calculate some rate or some percentage of a number, what you need to do is you need to basically divide this 20% to always 100%, okay? And just multiply this to your number. Well, this is going to be 20% from the 5,000, and you can see this, it's going to be 5,000 times to the 0.2. And if you need to add this to additionally to the 5,000, okay, I'm just going to take out 5,000 from the brackets. It's going to be 0.2 plus 1, right? Because if you take out 5,000 from the second term, from the 5,000, it's simply going to be equal to the 1. It's going to be 5,000 times the 1.2. You understand what's going on?
Yeah.
Okay, cool. So this is where this 1.2 is coming from. So later on, if I say here, could you please tell me what is the, so if the item cost 70,000 sims, if the item would cost 70,000 sims, and if it is discounted for 30%, what is going to be the final price? 30% off.
Yeah.
How I can find this? Should I multiply this to the 30%? 0.3?
Multiply by 70%. No, 70%.
0.7, right? So
Yeah.
this is actually equivalent to say that this is 70,000 minus 30%. Okay? Do you understand this?
Yes.
So 70% minus 30%, it means that you need to leave with 70% of the 70,000. And this is going to be obtained by just simply multiplying this to the 0.7. That's going to be 49,000. Okay. And analogously, you can do this thing with all of the other percentages. Okay. So this is very important concept. Now, later on, whenever we're going to talk about like simple interest formula or compound interest formula, it is very important to understand how you can calculate the percentages using these fractions. Okay. So
Yeah.
now let's do a problem. So let's say a person has money, $100,000, and he would like to invest his money into stock, into some companies. Okay. And he would like to get some interest after 1 year. So he can invest his money to the stock A and get 15% from his money. For example, if he invests all of his money to the stock A, then he will get 15% of the 100,000, which is $15,000. Okay.
Yep.
But the problem is stock A is not so stable. It's some company which is basically not so stable, and it is possible that he might lose all of his money if this company is going to be bankrupt. Okay. Instead, he can also invest his money to the stock B, to another company B, and interest is a little bit lower. It's only 10%, but company B is more stable. What this person wants is he wants to invest some portion of his money to the stock A and another portion to the stock B, so that his interest, his profit after 1 year is going to be equal to the $12,000. And the constraint here is that he cannot invest more than 50% of his money. So it's essentially more than $50,000 to the stock A. Again, so which amount of the money he should invest as a stock A and to the B in order to get interest exactly $12,000. Okay. So in order to solve this problem again, we need to create an equation which basically describes all of this process of investing money into these two stocks. Okay. So let's assume that X is going to be the amount of the money, amount to be invested to the stock A. Okay. And at the same time, what is going to be the amount to be invested to the stock B? If, for example, 10,000 is invested to the A, what is going to be invested to the B?
90.
90, right? It is going to be 100,000 minus X is going to be amount, is the amount
To be invested.
to be invested to B. Okay. So what is going to be the interest obtain it from the stock A is essentially X times the 0.15 is the money which can be profited from the A, right? For example, if I would just invest 10,000 to the A, then I would get 10,000 times the 15%, right? Which is going to be 150 from the A. And the interest which I will obtain from the B is going to be 100,000 minus X times the 0.1. Okay, so this is going to be actually interest from the A, interest from the A, and this is going to be the interest
B.
of B. I hope that you understand what's going on, right? So again, if you don't understand something, don't hesitate to stop and ask the questions. So altogether, he's going to obtain this amount. So this is going to be the total interest. And what he wants is he wants to know how much he should apply to the A and B, essentially find X, if this total interest should be equal to the $12,000. Okay, so we just need to solve this equation. We just need to find the X from here. So again, so this equation is used in order to understand all of this investments into the stock A and B. This is the essentially the meaning and the necessity of the equations in order to describe something. Okay, and I would like to solve this. In order to solve, I would just open all of the brackets and do the simplifications. It's going to be 12,000 is equal to the 0.15x. It is 15% of the x, which is what you have to learn from this lecture actually. So plus 100,000 times is a 0.1. It is actually 10% from 100,000. What is the 10% from 100,000?
10,000.
10,000, which is
10,000.
1/10, right? Okay, 10,000 minus 0.1x, right? Then I would just subtract 0.1 from the 0.15. It's going to be, and this 10,000 can go to the lab. Could you please mute your microphone, please? So it's going to be 2,000 is equal to the 0.05x. Okay. And if you just divide both of the sides to the 0.05, on the left-hand side, you will have 40,000. And on the right-hand side, you're going to have x. Okay. So the 40,000 should go to the stock A. 60,000 and consequently should go to the stock B. And in this case, the person is going to have the profit to be equal to the $12,000. And this is how we are going to solve, or how we're going to make the equations and how we're going to solve this kind of equations. Okay, so there is something which is called the zero factor theorem, which basically tells us that if two algebraic expression, the multiplication of the two algebraic expressions is equal to the zero, then it means that either one of them is equal to the zero, either another. So essentially, I think we can solve this kind of quadratic equations by factoring, but let me give you a bit easier example. Let's say x in a square minus 8x plus 9 is equal to the 0. Can you factorize this equation? So can you write this down as a multiplication of the two linear equations?
1 and 8.
1 and 8, right? So x minus 1 times to the x minus 8. Well, we can factorize this, okay? And x minus 1 times to the x minus 8 is equal to the 0. It means only two things, right? Either this is equal to the 0, either this is equal to the 0, okay? So this process, when we are going to write this down from the quadratic equation as the multiplication of the two linear, is basically called factorization. So you probably have seen that this process of the factorization have been one of the most important questions for all of the engineers for the whole history of the humanity, actually. So we've been, I think you're going to understand this, you're going to feel this after some time, because we're going to talk about a lot about the prime factorization a lot, and later on in linear algebra, you're going to talk about like a lot of type of the factorizations like QR factorization, or like diagonalization, LU factorization, and so on. So factorization is very important. So if you are able to write down a quadratic equation as the factors, then you can easily find its roots, right? It's going to be either x is equal to the 1 or x is equal to the 9. So this is what does this zero factor theorem tells you, that if you've got just two expressions and the multiplication of them is equal to the 0, it means that either one of them is equal to the 0, either the second is equal to the 0. And you can see here that the factorization is kind of the inverse problem, right? Because if I just give you these two linear functions, you can always write this down as a quadratic function. You can just always open up the brackets. But if all of the brackets are already open up, it is very difficult to bring them into the multiplication of the two linears, right? And you need to be really experienced in order to be able to do that. So in general, if you would like to solve a quadratic equation, so if you would like to find the roots or the zeros of the quadratic equation, you need to use this formula. So if your quadratic equation is given in the form of ax in a square plus bx plus c is equal to 0, then its roots can be found using this formula. So by the way, it is already put a constraint that a cannot be equal to 0. Could you please try to explain me why a cannot be equal to 0?
Because a is denominator.
Okay,
Because
so
if
yes.
a equal to the 0, there is no any x squared in the
Okay, yeah. If a is equal to the 0, then there is no x squared. It means that it is not quadratic equation anymore, right?
yes.
Okay, so if I would just not have this term, like for example, x in a square plus minus 9 is equal to the 0 without the term x, is it still a quadratic equation?
I think yes.
Are you sure?
Well, I think in that case, x has two answers.
-3 and 3.
Okay, but in this
Oh.
case, in general, with this one, x squared minus 8x plus 9 is equal to the 0 also has two answers, isn't it? Okay, so this is also quadratic equation. Okay, without x, it is also quadratic equation, not because it has two roots, it's because the highest power is equal to the 2. Okay, so it is a polynomial. So any polynomial with the highest power 2 is the quadratic equation. Okay, and if you have simply like without ax in a square, you have, for example, 3x plus 3 is equal to the 0, then this is going to be a linear function, or it's not going to be the quadratic equation. It's going to be a linear equation, okay? Because there is no the term with the x in a square. So this equation is called quadratic because of this x squared, okay? And if there is no x squared, then it is obviously it's not going to be called as a quadratic equation. So that is why a cannot be equal to the 0. I mean, if a is equal to the 0, then it's completely different story, okay? So if you've got this equation x in a square plus bx plus c is equal to the 0, then the roots of this equation or the zeros of this equation can be found using this equation when there is a mistake here, right? So we are going to do a small examples a couple of times right now. So where this term here, b squared minus 4ac actually is called as discriminant. Do you remember this?
Yes.
Yes.
Not. And discriminant should be equal to the more or equal to the 0, right? Because you're going to take the square root of this. And if this is less than 0, it means that it doesn't have a root, okay? In general, I can explain you how it works. So in general, do you remember how we call the graph of the quadratic equation?
Parabola.
Parabola.
Right? So
Yes.
parabola looks like this, right? So what you are doing is actually you are finding this point x1 and this point x2 along the x-axis. so that if you substitute this x1 and x2 into your equation, you're going to have
X.
0 on the right hand side part. Okay, so you're basically are crossing the x-axis. You're basically, so here at this point and here at this point x2, y is equal to 0, right? So that is why sometimes we call this as a zeros of the equations. You're finding the points when your curve is crossing the x-axis. So this is what does it mean, the root or the solution of the equation geometrically. Okay, so it is not the only way how the parabola may look like, right? So it may look like this, for example, right? When it crosses the x-axis just in one point, okay? At the same time, your parabola may look like this, where the vertex of your parabola is even higher. So this point is called the vertex of the parabola, the lowest or the highest point of the parabola. Or your parabola may look like this, when the vertex is going to be lower than the x-axis. In both of these cases, you're not going to have any solution, right? There is no point where your parabola is crossing with the x-axis, okay? So depending on this, you are going to have like 2 roots, 1 root, or no roots, right? So if your parabola is crossing with the x-axis twice, then discriminant is going to be strictly positive, okay? If your parabola is crossing with the x-axis just once, then discriminant is going to be equal to the 0 simply, okay? And if your parabola is not crossing with the x-axis at all, then discriminant is going to be negative, okay? No solution. Are you taking some notes as well?
Yes.
Yeah.
Okay. Okay. So we're going to talk about this in more details, even in more details later after a couple of lectures. But this is just let you know about the formula and how we can solve the quadratic equations. Okay. So let's
Yep.
do an example. So let's say we are given some quadratic equation of 3x in the square. So there was an equation here. 3x in the square plus x minus 9 plus x minus 10, sorry, is equal to 0. Is it like this? Cool. So let's try to solve this equation using this formula. First of all, I'm just going to evaluate the discriminant. Discriminant is going to be equal to the beta square, which is 1, minus 4 times to the 3 times to the c, which is minus 10, right? So 12 times 10 is going to be 120, plus 1 is going to be 121. Well, it's positive. It means that I'm going to have 2 roots, right? And the first root is going to be equal to minus b, which is minus 1. So plus square root of 121, which is 11, right? Do you remember?
Yes.
Yeah.
Square root of 121 is equal to 11. Why?
Because
11
11
quarter, it is 121.
121.
Okay, okay. Divided to the 2 times to the 3, or simply to the 6, it's going to be 5 over 3, right?
Yeah.
And x2 is going to be equal to minus 1 minus 11 divided to the 6, which is going to be equal to the minus 2.
Yeah.
Okay. The
Yes.
2 roots of the quadratic function can be found using this formula, and discriminant, and actually its sign, whether it is positive, negative, or equal to the 0, is going to tell you the number of the roots. And geometrically, you need to understand that the root of a quadratic function is nothing else as the point where this parabola is crossing with the x-axis. Especially, for example, for this equation, it is going to be something like this. So you've got this minus 2 here, and you've got here 5 over 3, and your parabola actually is crossing the x-axis in these 2 points. At the x is equal to the 5 over 3, and the x is equal to the minus 2. Okay, this is what does it mean? Finding the roots. Okay.
Yes, clear.
Yeah.
Cool. So sometimes we need to solve equations which involves the absolute value sign as well. So especially, for example, when you would like to express something which is connected with the distances, right? The last time we say that one of the main reasons why we would need absolute values modules is to be able to express the distances. And for example, if you just got some equation which involves some distances, then we need to be able to solve this as well. So solving, so let's try to solve this. So first of all, you just need to get rid of everything which basically involves, which is around the absolute value. It's going to be, I'm just going to put this 3 to the right-hand side part. It's going to be 2 times x minus 5 is equal to the 6. Okay. Then I'm just going to divide both of the sides to the 2 so that I will have absolute value of the x minus 5 is equal to the 3. Okay. And do you remember how we then do the next step? The next step is we need to get rid of the absolute value, right? But we can't really just do this because we need to put some constraints, right? So we need to say that if x minus 5 is positive, so essentially if x minus 5 is positive, or simply if x is more than 5, then I can simply get rid of the absolute value sign. And it's going to be x minus 5 is equal to the 3, then x is equal to the 8. And indeed, if I just substitute x to be equal to the 8, to here, it's going to be 2 times the 3, which is 6, plus 3, it's going to be 9, which is true, right? If x is more than 5. But at the same time, x minus 5 can be negative, right? In this case, if x is negative 5, okay, what I have to do is
X equal to 2.
x minus 5 is going to be equal to the minus 3,
Minus 3.
right? Not to the 3, but minus 3, okay? If this number is positive, then you're going to just get rid of this without changing the sign of the right-hand side part. If this number is negative, then you have to change its sign. It's going to be x is equal then to be equal to the minus 2, right?
Plus 2.
Plus 2, sorry. Plus 2. And then again, I'm just going to check this. It's going to be 2 times to the plus 2 minus 5 from the module, right? From the module, which is going to be equal to the 3. Plus 3 is equal to the 9. Okay? Then everything is going to be correct. But if you would just put minus 2 instead of plus 2, what would you get? It's going to be minus 2 minus 5, right? Plus 3 is equal to the 9. Then it is going to be 7 times the 2 plus 3. It's going to be 17 is equal to the 9, which is obviously not correct. Do you understand what do I mean by putting minus 2? If you would not change the sign here, if you would just keep this to be equal to the plus 3, then you would probably have the wrong solution. Again, so in general, this is your strategy or your algorithm. If x is equal to the a, then it means either x is equal to the a or x is equal to the minus a. Okay. Similarly, if you've got essentially x plus 5 in the module is equal to the 11, it means either x plus 5 is equal to the 11 or x plus 5 is equal to the minus 11. Okay. So you need to get, whenever you get rid of the absolute sign, you need to just equalize this to the plus right-hand side part and minus right-hand side part. It is how we are going to deal with the equations which involve the absolute value sign. There is one more type of the equations which are really important. It is the equations. So you see, so it is not a polynomial yet, okay? So this is not polynomial. This is not polynomial neither, okay? Polynomial again is going to be always coming strictly as in the form of ax in the power of n plus and so on plus a0 is equal to the 0. Okay, so this equation contains the radicals. So I think this is one of the easy examples because I think we easily solve this. So one way to deal with the equations which involve the radicals is to just keep the radical in one side and everything else in another side. If it is possible, then great, you can solve the equation. Okay. So what I want is I would like to just keep this radical part in one side and all of the things to the other side. It's going to be square root of 3x plus 1 is equal to the x minus 3, right? Because whenever the 3 goes to the right, it's going to go with negative sign. Okay, so you've got 3x plus 1 in the power of 1 over 2 is equal to the x minus 3. So what you need to do in order to get rid of the radical?
Quadrate x minus 3 equality.
So we need to square both of the parts, right? We need to square this part, the left-hand side part, and we need to square the right-hand side part as well. Okay? And if you square the left-hand side part, you can know that 1 over 2 multiplied as a 2, it's going to be simply 1. So that is why you're going to have 3x plus 1. And on the other side, on the right-hand side part, we are going to use the formula. So which is like, do you remember this formula? So x plus a in the square, there's a formula, x in the square plus 2ax plus a in the square,
Yes.
right? We're simply going to
Yeah.
use this equation. It's going to be x in the square plus 2 times to the x times to the minus 3 plus minus 3 in the square. So, well, it's going to be 3x plus 1 is equal to the x squared plus 6x plus 9. And now I'm just going to put everything into one side. So let's just get
Minus
this term and
3x.
put this two
Sorry,
here.
Professor.
Minus 3x.
Okay. Okay, so it's minus here, right? Okay, so this is going to
Excuse
be
me,
x in a square. Yes.
Professor. After the formula, I mean, this is gonna be x squared minus 2 times x times minus 3.
No, it's always plus. Okay, so sorry for
Continue.
sorry for confusing
Mm.
you. I mean, you can do two formulas, right? You can do this x minus a in the square, and you can do this x plus a in the square. Okay, so what I just did is that I just wrote down x minus 3 as x plus minus 3 and just apply this formula. Okay.
Oh, yes.
You are
Understand.
going to have the same thing actually. Okay, so I hope that you understand what I did. So
Yes,
I just
it's
used
clear.
just one formula. X squared minus 9x plus 8 is equal to 0. Then we can easily solve this by factorizing this equation, right? It's going to be x minus 8 times x minus 1 is equal to 0. It means that either x is equal to 1 or x is equal to 8. We can just put both of these numbers into the equation and check whether they are the proper solutions or not. So please don't forget about this, that you need to check whether you've got the proper solution or not. So this is what I wanted to discuss with you today. I wanted to discuss with you about the equations, their importance, of course, in mathematics and in our lives. So we've discussed about how we can solve the linear equations, quadratic equations, equations which involve the absolute sign, or the radicals. And also, I hope that you understand, you have some feelings about what does it mean, solution of the equation, right? So strictly defining the solution of the equation is the number or the set of numbers, so that if you substitute them into the equation, the statement is going to be true. Geometrically, it means that if you've just got a graph of your equation, it is the points when they are crossing with the x-axis.